Hello, everyone. This is Bruce Belzowski. I'm the managing director of the Automotive Futures Group uh, here in Ann Arbor, Michigan. This is part of our series of industry insights on the automotive industry. Today, we're focusing on autonomous vehicles. And today with us, we have Missy Cummings from George Mason University, who's an expert on robotics and artificial intelligence. And we'll be talking to her today about some of the issues related to autonomous vehicles. Missy describes herself as a technological realist. I'm pretty much in her camp right now, but I think to hear it from her, I think it's something that we have to do today. We'll also be talking about some other issues related to autonomous vehicles. Welcome, Missy.
Thanks for having me.
Missy, can you give us a little background on your experience? I know that you at one time were a fighter pilot.
That's right. That's right. So in my first life, I flew fighter jets, A4s and F-18s for the Navy, and lived all over the world, have landed on aircraft carriers, and then largely in part due to my experience flying F-18s, where I saw, in the 3 years that I flew F-18s, on average, I saw someone die once a month, someone that I knew, and it was always human-machine interaction problems. It was never because of war. And so that really motivated me to go back to school and get my PhD in cognitive systems engineering, which is really human-machine interaction. And so I got my PhD, went to MIT for 10 years, then I was at Duke for 9 years, and now I'm at George Mason in the Washington, D.C. area, helping them build an autonomy and robotics center. So I've spent the bulk of my life either flying, operating, or researching autonomous vehicles.
Very good. Now, Missy, when you look at the autonomous vehicles that we see on the road today, where do you see them in terms of their development? How far along are they? And then we can get into some of the challenges and where they're lacking.
Well, autonomous vehicles today, if we're just going to limit this conversation to the surface transportation community, I would tell you, and there's lots of other vehicles we could talk about. I think my favorite application of autonomous vehicles is in mining, because this is the best place, I think, to use autonomous vehicles. But if we limit our conversation just to surface transportation vehicles, we've got companies like Waymo and Cruise trying to advance passenger robo-taxis. Then there's companies like Aurora and Kodiak who are trying to advance robotic trucking. And then there's, I would say, the third major effort are the companies that are trying to do people movers, the Zooks, the shuttles, the Ollies, for example, the Beeps of the world. So
we have one here in Ann Arbor called May Mobility.
That's right. That's right. May Mobility's in that camp. So I think that there's all sorts of like smaller, we could do the cargo neuros. And even if you wanted to start looking at sidewalk delivery, there's a lot of other smaller companies, but really the people movers, the trucks, and the passenger cars, the robo-taxis, those are the three major efforts.
Yeah, yeah. So when you look at their evolution, where do you see them? How do you see them? Where they are in their evolution?
Yeah, so these different domains are advancing at slightly different rates for obvious reasons, because they're different domains. I would say that the passenger cars, the robo-taxis, you cannot argue that they don't work, because they do work. I mean, at least to some degree. So Cruise and Waymo have operating services in California. In theory, they're making money. So they have made a lot of progress. And I think that people should give them credit. As an engineering professor, I'm really amazed and wowed at their progress. I think that commercializing this technology has basically meaning taking it away out of the military and putting it in the civilian sphere, has done wonders for the advances of this technology that now the military is benefiting from. That being said, there's still a lot of challenges, and I'm not going to go too much into that now because I know we're going to spend some time on that later, but I think it's suffice it to say that the passenger cars, the robo taxis, have proven that they can work, but maybe not work in all places at all times. The self-driving trucks are a completely different story. They're still experimental. They have not transitioned to any kind of commercial operations. It's a much bigger prospect of injury when you're moving tonnage, that massive tonnage at 65 miles an hour down the highway. So I think, to their credit, the self-driving truck companies are taking this slower and at a more measured pace, which is good. I am less optimistic about that field because, as we're going to talk about, neural nets, artificial intelligence in vehicles, it's not turning out to be what we hoped it would be. And so I'm not entirely sure that industry is going to be able to get over some of the technical hurdles because of the risk. The people movers, it's kind of a mixed bag. The people movers, I think, have the best opportunity, as long as you keep the speeds down, to be successful. But one of the problems that all three of these major groups have are phantom braking. This is a real nightmare. And I've seen a lot of phantom braking in the shuttles. And that's a problem more than it is, I think, in the cars, because people are not built it in. People take shuttles to short distances. We've seen some injuries already. So I think that the people mover shuttles in slow speed on constrained routes could be a very successful application. But we got to get this phantom braking problem addressed, or that could be the showstopper.
Right. When you look at phantom braking, have you done some work on the technology itself to see what are some of the reasons it's doing that?
Yeah, so I first became aware of this problem while I was the senior safety advisor at the National Highway Traffic Safety Administration. I saw it both in accident analyses that we were doing, investigations, but I also saw it in the standing general order of data. And you yourself, anyone can go get that data on the internet and analyze it. And what you'll see is that the self-driving cars in California and other places are being rear-ended at twice the rate that other cars who are not self-driving cars are being rear-ended. So that was my first clue, coupled with these accident investigations where I could actually see what happened. And indeed, it's just continued to spiral. And this is not just a self-driving car issue. Teslas have been infamous for the phantom braking problem, but it's not just a Tesla problem. This problem of phantom braking will exist in any car where you've got artificial intelligence being used by its computer vision system. That is all cars that embed autonomy, whether or not we're talking about self-driving or driving assist. And it's the drum that I'm beating right now, is that you cannot ignore this phantom braking problem. And we are ignoring it. Regulators, state and federal governments are ignoring it. The car companies are ignoring it because they're being allowed to ignore it, because when we have a rear-ending accident, we blame the driver in the back, because that's the way our legal liability in this country works. If you rear-ended a car, it's your fault. And so no one is doing a deeper investigation. But what I have seen in these investigations, what you can see in the data, is you can be following a self-driving car at more than a 2-second following distance, which is what you're taught in school is a safe following distance. But when a car in front of you, we can take the example of the San Francisco Bay Bridge tunnel accident last Thanksgiving, where a Tesla had a hard braking event, and then there was an accordion, 8 other cars rammed into the back of each other. These cars were not all following at unsafe distances. What happens is the car behind the Tesla could see through the Tesla's windshield. And we've all been there. You're driving, you're looking through the windshield of the car in front of you. You can see that there's nothing in the road in front of them. And so that helps you gauge your speed, your following distance, how comfortable you are at turning the dial on your radio. And then, and on that day, when the Tesla did a hard braking maneuver and there was nothing in front of that car that caused that, it caused this cognitive dissonance for the second driver who's driving, and you're thinking, you think to yourself first, why did that happen? Like, what? Why did we all just brake? And then even that split momentary pause and you trying to figure out what just happened, then you get on the brake, then it's too late because you're well within inside that distance. And so I think that we do not appreciate that following and braking is actually a social system as well. And the last technical piece of this puzzle is cars brake harder, they brake faster. Their reaction times are far greater than humans. And so humans are also not attuned to braking for a robot who's also doing hard braking.
Mm-hmm, mm-hmm. Now, Missy, the government has regulated, but I think the manufacturers are doing it on a voluntary effort, the automatic braking systems that they're putting on new vehicles, right? And I think it's still voluntary, but most of the manufacturers are doing it. Is that really just a forward collision mitigation system in effect?
Well, I can't speak for every car company, but I don't want people to confuse AEB with just regular braking, right? So emergency braking, automated emergency braking, there will be typically a certain window of speed, let's say from 20 to 45 miles per hour. I mean, you have to check your owner's manual because it'll be slightly different for every car. But the idea is that the cars detect some potential obstacle. Presumably, its sweet spot is that there's another car in front of you.
Right.
And so, especially for radar, that change in velocity of the other car in front of you is the key signal that it senses on. So right. AEBs are not perfect. They also have occasional problems, but on the whole, AEB really helps reduce crashes, really helps drivers from colliding with another car in front of them. Mm-hmm. These are not the same systems that, at least that we think. I mean, that's the other problem, is that because there hasn't been a widespread investigation into phantom braking, it's hard to say across the board, are the same signals being used? Are they not being used? But typically, at least as far as I've seen in these systems, the systems that engage in a hard braking, it's not being flagged by the AEB system. It's the system itself. It's the computer vision system that's doing regular braking and acceleration, the drive-by-wire in the car, and somehow the perception signal just triggers a braking event. Now, I mean, I leave open the door that the AEB could be accidentally being engaged, but we need more data and we need the car companies to be more forthcoming on this point so we can get down to the bottom of this.
So it may not be a high-speed automatic braking system. It's more of a lower speed automatic braking system, or it depends on the manufacturer?
Well, AEBs are lower speed.
It's always lower speed.
They're not supposed to be, although, companies, I think this is a point of research for companies, but it's the sharp, unexpected braking. A phantom braking is typically just the system itself doing a hard braking maneuver, which is around negative 0.5 Gs, which is not necessarily the same as an emergency braking maneuver.
It's emergency for the people in back and behind them.
Right. So now you have a emergency created where none really existed.
Right. But you know where I'm going with this. You gave an example of how the phantom braking creates the accordion effect of cars crashing into each other. If all 8 of those cars had emergency braking systems, would they have been?
I think it's a good question, but if they don't work more than 45 miles per hour, the answer would be no, because everybody
absolutely.
justify.
absolutely. Yeah, yeah. But let's say they did work.
I mean, in theory, and you know, a manufacturer would like to get to that point.
Yeah,
I think
yeah,
that it is, if we had, if everything was a robot and there weren't any human reaction
right,
time,
right,
perception was perfect. Could the robots have sorted this all out? Absolutely. I mean, we've
okay,
known for a long time that it would be better to have self-driving technologies either for everyone or for no one, is
yeah,
because if everyone had them, then the robots could talk to each other.
yeah,
But at
yeah.
this point in time, it's pretty dangerous because we have Pintos and Gremlins on the road
That's
with
right.
Tesla.
That's right. That's right. Yeah, yeah. This is it's it's a huge challenge for the AV folks when they're talking about integrating them into the current system. But one of the integration projects, one would argue, is our ADAS systems, where where computers are doing a lot of the work for safety issues, and you as a driver are still in charge, and you are responsible, and you as you drive these vehicles, and you know this is something that I've been talking about for a little while now. You know, if but it's going to take so long to penetrate all the vehicles on the road so that all drivers get access, will have had access to these advanced systems and have gotten used to them. You know, they're used to the vehicle nudging me back into my lane. They get used to it, of seeing the blind spot light go on, and feel confident with the blind spot, instead of feeling they have to look over their shoulder to make sure, which I still do. And they and they'll have emergency braking systems. Of course, people could overdrive their vehicles, as they already do, thinking that these technologies are going to save them. That's another issue, right? Um, but what do you think of the idea of the transition? What is the best way? Is it reasonable to consider ADAS as a transition to AVs?
I don't see it that way.
Okay.
I see that we have two paths of autonomy in vehicles.
Mm-hmm.
It's either driving assist or self-driving. You know, and you know, people want to say, well, driving assist is the necessary first condition, the first step before you get self-driving, and that's
Right.
not true. Waymo and Cruise did not have to have driving assist first, right? I mean, they
Right.
just went straight to self-driving.
Right.
So, and
Technologically, they did not have to.
that's right.
Right.
And I think that the problem with, if you're trying to say that ADAS has to be for drivers, if you're going to use them to basically psychologically prepare people for self-driving cars, the problem with that is that when you put people in a car and it's doing a lot of the driving by itself, but still requires the human to intervene every now and then, it really is causing people to mentally check out, and we get huge distraction,
Yeah.
beyond distraction, right?
Yeah.
And so one of the things, you know, I have my whole first career in aviation, the number one killer of attention is boredom.
Mm-hmm.
We see this all the time in aviation. We knew about it way before self-driving cars even came around. So this was entirely predictable, that as soon as you take the driver out of the immediate control loop, they get bored, their minds wander. They don't even have to have a cell phone in the car. We've seen plenty of accidents, plenty of deaths where people were killed, and they had no cell phone, and they were not necessarily looking.
They weren't distracted that way.
Yeah, right, exactly. I mean, we've all been there where you're driving down the road and you missed your exit because you were thinking so hard about something else. So you don't even have to have an external device in the car to make you very distracted. So I think that if we want to get people to appreciate self-driving cars, which right now the American public does not want, So survey after survey after survey for the last 10 years shows that your average American doesn't really want a self-driving car, is not interested in them at all, doesn't want one, doesn't want to ride in one, and these numbers are only going up. So I have to tell you, I'm not sure when you say, how do we then socialize people to self-driving cars? You know, I'm not really sure we should be messing with people's free will here, right? You know, it seems to me that maybe the public is starting to appreciate that this is a harder task than it is. So should we be trying to convince people that self-driving cars are great and awesome? I don't know. I mean, I think that's a hard ethical question, because I don't really think the cars are safe enough in my mind to start some kind of campaign for changing the public's attitude. I think that very much like cell phones, I mean, this is why BlackBerry lost its cutting edge and hold on the cell phone market. There was another product that showed up, the iPhone, that made life much easier. It was simple to use. It really meshed well with people's everyday lives. It's not clear self-driving cars are going to do that, or if they're going to do it, what the right market is. You know, I think doing cargo delivery of last mile groceries using self-driving cars, that's awesome. And you could appreciate, for people who can't drive or live in urban environments and don't have cars, you know, this would be a really, really useful tool that could integrate into their everyday lives. But beyond, you know, beyond the need to have something delivered to me, I'm not still sure that a self-driving car that moves erratically, that takes obscure routes, that can drop me off in the middle of the street instead of pulling over to the curb, you know, is this really helping me? Is this really making my life easier? I don't think we're there yet.
I think those are reasonable responses, because it's kind of like, what's the end game here? Where do you really want to go? You and I were speaking just a little bit before the interview about how the new mobility people are not really excited about autonomous vehicles unless you're really talking about autonomous buses or autonomous trains. But having each person having their own individual autonomous vehicle, kind of doesn't really help with congestion, doesn't really help with fuel economy. It's just a different form of what we have right now. So that's one part of the story, right? When you look at, I guess I want to go back a bit back to the transition story. I appreciate your thinking about, there's not really ways of, you know, an easy way of transitioning people to this, or for people to think that this was something that they would be helpful for them. I think the automatic braking system story for forward collisions is a nice one. I know I myself have been in those accidents, unfortunately, luckily not serious, but you know, distracted, and the car in front of me does a hard brake, and I didn't react in time. And at low speeds, that automatic braking system probably would have saved me. And so I think that there's some really nice potential for low speed accidents to be avoided because of this. But that doesn't make them autonomous vehicles, right? It just means that there are some aids to you as a driver that will not distract you and not make you feel lazy. Do you think it's the combination of them it's the combination of all the technologies that, you know, forward collision mitigation and warnings, blind spot detection, actually some people will have rear and side detection as well. Do you see those at the combination of those as being a problem in terms of, I guess we would call it distraction, because you're talking about being you're being, I don't want to say the word lazy, but not paying attention as you should be.
Yeah, no, I mean, when we start talking about autonomous technologies, I think the SAE has made the situation worse by continually changing their definitions. You know, I have a pretty easy rubric here. There's nice to have autonomous technologies and must have technologies. Must haves are the ones you just talked about. Must haves, AEB, blind spot detection, forward collision warning. These should be mandated to be on every car. They're not perfect, but they are so good that they're helping people avoid collisions far better than if they were not there alone. And research study after research study has shown.
Right.
So the must-haves in terms of autonomous technology on cars, yes, the safety focus. The nice-to-haves are convenience focused, and this is autopilot, Blue Cruise, Super Cruise, any technology that does lateral and longitudinal control for you. Other than maybe lane warning detection, which I'm a big fan of, but that's not what we're talking about. We're talking about cars that move you in and out of a lane and move you around other vehicles in front of you. I am a big fan of cruise control. Automated cruise control is fine, but to me, that's where I draw the limit, because when we start doing lateral and longitudinal, first of all, you don't really need that. That's not a safety feature. It's a convenience feature. And this is where we start to have the problems. Like as soon as you get past cruise control on any set of autonomy features, that's where we start to see distraction really kick in.
Okay, that's a good point. Good point. I like that distinction. I hadn't really thought about it in that from that perspective, because we always get this whole package story. You get the whole package. You get to do all this stuff, right? And just because you have the package doesn't mean that the individual pieces are not really good, or their convenience versus must-haves. Yeah, very, very nice way of looking at it. When you look at government's role here, I think you've been pretty critical of how the government has been approaching this. Can you talk to us a little bit about how you see government role in AVs?
Well, I mean, I have been critical, and then the National Highway Traffic Safety Administration asked me to work for them, and there's nothing like seeing how the sausage is made to have an appreciation for the challenges that they really have. So, you know, I am critical that more needs to be done, but I'm also here to tell you, having worked on the inside, that it's not as easy and straightforward as people think it is. So I like to use the example of who regulates the driver in a car. Well, in cars that we drive with no autonomy, NHTSA is in charge of making sure the technology on the car is safe. But the states are the ones that determine whether I, as an individual, am sufficient to be a driver. But now that we have autonomy, whose job is that to license the driver? And so there's this weird middle space where could the states test this car's drivers? They could, and I think they probably should. So that onus now falls on the states. NHTSA's issues are, well, we've got to make sure that technology on the cars, first of all, that the cars have the basic technologies that are required by the FMVSS, the Federal Motor Vehicle Safety Standards, which, I mean, they're so old, they're out of date. I mean, they really don't apply to self-driving cars, for example, and even maybe a lot of driving assist cars. I mean, that's a point of debate right now. So it's not clear if a car meets all the FMVSS, and indeed, a lot of the cars that are self-driving do meet the basic. They're just regular cars. They have the windshield wipers, they have the seat belts, they have everything required. And so FMVSS doesn't say anything about driving assist systems or AI in the cars. And so now we're at a crossroads where the technology has leaped far, far, far ahead of the regulators, which is typical for any kind of emergent technology. And it takes years for rulemaking processes to catch up.
Right.
So I think that in the interim, NHTSA is trying to figure this out. I think that they are severely hampered, as are most government agencies, in having the right people work in the agencies. I think that the US government as a whole, and I think the DoD, Department of Defense, and the Department of Transportation have a particularly acute need for people with artificial intelligence skills, which they can't get because we're not producing enough in the country, and the government doesn't pay very well. So why would you go work for the government when you go work for Google, for example, and make 5 to 10 times more money? So I think that the government agencies are trying to move forward, both federal and state, but I think that we could and should do more. I think, first of all, there needs to be a consortium between the federal government and the state agencies to help them share data and lessons learned. So, for example, right now, the standing general order that is this federal document where all companies have to report crashes, they report crashes that includes a lot of detailed information that is then redacted so the average person can't see them. But the states really do need to see this data to really understand where their hot spot areas are. But because federal and state agencies can't talk to each other, they can't share the data. And so that's really hurting the state agencies not to be able to see federal data. So I think those kinds of problems need to be worked out from a legislative perspective, because the state agencies, if you think the federal government doesn't have enough people that are working on AI, it's definitely true at the state level. Mm-hmm. So I think we could do more to encourage the state and federal governments to work together. I think that specifically some new laws need to be passed that require driver's license tests, vision tests, if you will, for any car with artificial intelligence in the computer vision system. We see it every day. The phantom braking is a problem, but also not seeing things that are really there, like semi-tractor trailers sitting broadside, fire trucks in the lane. If a car can't see those, if we were blind, we could not drive. Humans could not drive. So we know that there's instances where the cars are blind. If they're blind, especially in everyday circumstances, which fire trucks and semi-tractor trailers are, they should not drive until we're sure that they can see. So I think that there are some necessary steps, but just as I referenced before, oh my gosh, like who's in charge of that? Is the state in charge of that? Is the federal government? So I think that there's, who has the statutory authority to bear on this? I think that's still a problem. But I would say the last set of responsibilities that I would like to see changed are in companies themselves. I think the companies have a huge area of responsibility here. The software in self-driving cars and driving assist cars is as complicated, if not more complicated, than what we see in commercial aircraft today. So in aviation companies, there's a chief pilot that signs off on every aircraft. When Boeing puts out a new aircraft, there is one man or woman that stands up and says, I am a chief test pilot. I have been over everything. I have been over the code. I have been over the hardware. I am guaranteeing that this meets minimum levels of safety. And I feel comfortable, me as an individual, I am signing off on this. And you can see our safety numbers in aviation. Since we instituted chief test pilots, they're eye-watering, right? We achieve nearly perfect safety records every year. I agreed, occasionally we have problems, but the problems are so low compared to, we have 10 to the minus way out there numbers of crashes.
To miles flown.
Right, to miles flown, as opposed to, we're increasing people's deaths on the roadways. So here's what I want. I want companies to stand up and say, we have a chief AI test pilot. And every time we do a major software release, or we put a new self-driving car on the road, I signed off on it. I ensured that this was safe enough. I'm not saying perfectly safe, but safe enough to at least be as safe as a human. And I think that if we had clear lines of accountability in surface transportation and self-driving, you would see much, much better products on the road.
Very good. Well, Missy, when you look at the future, automotive futures, you're going to get some future questions. You got to get you can't talk about automotive futures without talking about the future. When you look at, say, 5 to 10 years out from now, where do you see AVs? What kind of state will AVs be in by then?
Okay, well, I'm gonna be a little controversial here. I think AV trucks will still be squarely in the research camp. I think we will see spotty shuttle success, meaning not just in the US, but there'll be little pockets of success, people movers all over the world.
Especially if they have their own lane.
Yeah,
but if they have their own lane, now they're monorails or something like that, right?
But even so, even in mixed traffic, I think we'll see some successes. I think we'll see delivery be still increasing. I think robo-taxis are going to remain a novelty. I think that they will be around, but they will not be ubiquitous, and they will only be in certain cities. I think that we are seeing, especially with what's happening in San Francisco right now, this is a city that's had enough, and the people and the city employees don't support this technology anymore. And I really don't think that it's probably a healthy business dynamic to have all the firefighters and police officers not like your company. Like, to be perfectly honest, I wouldn't want to operate in a city if I thought the police had a grudge against me, or the firefighters, So I think that there'll be cities that maybe welcome these technologies, and in those cities, the cars will have more success. But I don't think they're going to be everywhere. And I don't think that the numbers are going to, I don't think demand, forget all the technical problems, I just don't think the demand is there that's going to buoy up large scale deployment of self-driving.
Even within 10 years.
Yeah. Even within 10 years.
Yeah. I know that we've had at the University of Michigan here, we had a what was the French group that had a shuttle that was driving around the parking lot. Navia, I think. Navia. Yeah. And they were driving around in a it was a closed area. It was not on the streets, but it was a big complex, so they could actually do this. But what did you see happening? You would see this autonomous vehicle come to a stop at a stop sign, and another car coming from the side was also coming to a stop sign, right, at a say a 3 or 4-way stop, and they see that is an autonomous vehicle, and they blow right through the stop sign because they know the autonomous vehicle is going to stop, and there's no person there to get mad at you for cutting them off, for not doing what you were supposed to do. I was so surprised when I first saw that just in this small circumstance, that once people get accustomed to seeing these vehicles on the road, they will take advantage of them. Not in a good way, but in a bad way, in a less safe way. That one really struck me. And in the future, well, I guess you could have cameras. They probably have cameras on those vehicles. They could get license plate numbers of people who run stop signs, et cetera, et cetera. I think I've heard some examples in San Francisco where people jumping out in front of the vehicles to slow them down, just to freak them out. So there's kind of I've seen on some of the robo deliveries on sidewalks, seen some videos of bad actors flipping them over. It assumes that everybody is a responsible citizen, and this, unfortunately, not everybody's a responsible citizen. So I think it brings in another issue related to autonomy. So, Missy, I think I want to thank you for your time on talking to us about AVs. Is there anything else about AVs that I haven't really talked to you about? You think we should be talking about?
No, I mean, I think you've hit on everything. I do think that companies need to think harder about how they're positioning themselves. I think San Francisco, when there started to be a lot of pushback from the public and the first responder agencies, the company's response, knee-jerk response, was to then try to say humans are all bad drivers. 94% of all accidents are caused by drivers. You drivers are terrible. And that's what we're here to try to replace. And, people are just not in the mood right now to be talked about being replaced. It's not a good, it doesn't give you the warm and fuzzy. And so I would encourage companies, if a city doesn't want you there, I'm not really sure you should continue to push a bad situation. Go to a city like New Jersey, where Elaine Kornhauser is just begging you guys to come. Go where people want you, and you will likely have more success. But if there's nothing I've learned more than being a mom of a teenager, is stop pushing a bad situation. It's not going to get any better. You need to take a break.
Mm-hmm. Mm-hmm. Very good. Thank you. For the second part of our discussion with Missy, we're really focused on artificial intelligence within autonomous vehicles. Now, our conference that's coming up on September 12th is talking about AI in the auto industry. Well, that can be AI in manufacturing, of robots inside of factories moving materials around, robots doing work on putting vehicles together. Robots have been in factories for decades now, and artificial intelligence in terms of machine learning has been in factories for decades now. But we're looking at kind of like a next generation of AI. We're going to see I'm sure it's Missy's going to talk to us about how that is playing out within AVs. And then we also want to talk a little bit more about how she sees generative AI playing out in autos. Missy, can you talk to us a little bit about how you see AI currently being used in AVs?
Well, so artificial intelligence can be used in a couple of different ways, actually multiple different ways. When you hear about machine learning, that typically means neural nets. And so that where you find neural nets in autonomous vehicles is primarily in the computer vision system. So the neural nets, for example, learn. You show them a million images of a stop sign, and they will learn to distinguish the outer edges of a stop sign, the outer edges of the word stop, and they understand to statistically correlate the edges of those images with this thing known as a stop sign, and that thing is associated with bringing the car to a stop. So that is one area of AI that those same neural nets can also be used, or similar neural nets, to do driver monitoring. So this is where you see in driver assist. So you can train the cameras, you train them on a million faces, and you train the neural nets to recognize that this is asleep, this is awake, asleep, awake, right? And that's how the cars actually potentially learn to identify someone who's not paying attention. Mm-hmm. Mm-hmm. These neural nets are easily fooled, both the computer vision that looking out and the ones that are looking in. People can wear sunglasses and fall asleep, and that's enough to defeat some human machine monitoring devices. Depending on how you're looking over here, looking there, you can defeat these devices. In the cameras that face out, that artificial intelligence in there, and we saw this with Cruise in San Francisco. They had an accident where one of their vehicles rammed the back of a bus. How is it possible that a car with LiDAR could actually hit the back of the bus? Well, it turns out that they had decided that for these kinds of engagements, that the computer vision system would be the primary sensor and the LiDAR would be the secondary system. Mm-hmm. And they only ever trained their computer vision system to recognize regular buses. But this particular bus that got hit was an articulated bus that kind of bends in the middle, and goes like that. Which were everyone commonly encounters articulated buses when you drive in San Francisco. So the neural net in that case was blind because if they don't recognize something that they're seeing, then they see nothing, and thus it rammed into the back of the bus. And the LiDAR was never called on because the system didn't know that it needed to call the LiDAR. So, AI has a lot of problems, that kind of, and we call that connectionist AI, neural nets. There's other AI in the car that more symbolic AI in the navigation system, like, for example, that's planning and doing a particular path generation, right? So this is more deterministic AI that we know that works very well. So I don't worry so much about that AI. What I really worry about as a researcher is anywhere where computer vision shows up.
Mm-hmm. Very good. When we look at the technologies that are currently on, you discussed those, what do you see as the next wave of AI improved technologies for AVs?
Well, I don't see any new dramatic changes coming for AVs. For example, if a car manufacturer tries to integrate ChatGPT or other large language models into the car, this is going to be a nightmare because ChatGPT and other large language models are so error prone. So I don't think that should come, although people swear they're going to do it. So that's definitely going to be a car that I won't be buying. But I think what hopefully is going to happen is that the computer vision systems get better over time. We need to figure out how to do better training. We need to figure out how to do better testing of these algorithms so that we know when they're in domains that they really can't handle. So I am hoping that the idea of AI maintenance really takes hold, where we understand that you've got to do better quality assurance of the AI that you've got in your system, and you also need to make sure that your models continually stay relevant. So for example, every time a new car, as soon as the Tesla Cybertruck gets into the market, basically every neural net on the road, no matter who the manufacturer is, needs to retrain their neural nets to recognize the Cybertruck. It's such an unusual vehicle, it may not be recognized as a car. So you have to do retraining. Retraining is expensive and it takes time, and companies are loath to do that. So now we're also going to start thinking about regulatory, how are we going to regulate the retraining of these systems? Are we going to use standards? Will some standard agency come out and say, you need to be retraining on this kind of time scale or under these kinds of circumstances when new cars get involved? Nobody's talking about that now.
Mm-hmm, mm-hmm. Yeah, when we for one of the plugs for my former employers, the U of M Transportation Research Institute, one of their some of the work that they have been doing over the last few years was doing simulations, and that they had figured out ways of doing simulations so that they, especially for connected and autonomous vehicles, so that they didn't have to be on the roads all the time trying to generate this. They could do it through simulations. And I think that the generative AI, they're talking about using that as well as a training mechanism for a training AI. Does that jibe with what you're expecting?
Well, I mean, you just said generative AI, and I just canned large language models, and they're very close. So I'm not saying generative AI can't be helpful in simulations. Maybe, but I think one of the things that we've seen in the self-driving community is that car companies are too reliant on simulations. I'm sure generative AI can be helpful to some point, but companies have to recognize that there is a time and place where you have to fish and cut bait and get out into the real world, because your simulations are going to be tuned to give you idyllic responses, and also responses that may not match the real world. I know of no simulator today that can capture the weather conditions in Michigan accurately. So to do that, to find out if your car is going to work in Michigan, you need to drive it in Michigan in the real world.
Very good. Yeah. When I've been tossing and turning with this generative AI story, and played around ChatGPT and stuff like that, and this to see how it might play out. One of the I don't see it as something that can be used in a mission critical situation. Definitely not now. But I was thinking it as a more of an informational support for drivers. And when I think of this, and I wanted to get your perspective on this, because I may not be thinking clearly about this. Like ChatGPT is made up of everything on the internet that it could scrape off the internet, probably all of Wikipedia and everything else that they could scrape off and then use that as their background for whatever question you ask them, right? In a vehicle situation, could manufacturers create their own background data set that would be used for their chat GPT, so to speak, so that if you asked a question about your driver's manual and something about, where's that button for the releasing the trunk, for this vehicle? Can you see that as being useful within the context of a vehicle if you limit the data set that the chat program or the generative AI uses as its base?
At that point, I would say if you just want to provide somebody the ability to search your manual, you just need to leverage good search algorithms, right? I mean, ChatGPT is like a nuclear bomb when you're trying to hit a very small nail in that kind of situation. So, I do think that, but I think it's interesting that you asked that question, because it goes to show you that people are just going so crazy and they're running so far ahead in their minds with ChatGPT that they forget, look, we actually have some pretty good search functions. And if we only, if searching car manuals to find out something relevant, maybe we should spend some more time making user-friendly search algorithms as opposed to trying to use the nuclear bomb of ChatGPT. The real concern that I have in these large language models, I basically have two concerns. Just the quality of data that gets scraped by these algorithms that gets included. There's research already starting to show that when ChatGPT goes out and gets other data that was generated by large language models, the performance of ChatGPT goes way down. So large language models should not be learning from data that's generated by other large language models, and so that's a big problem. But from the other issue that I'm really concerned about in the automotive community is the number of students, junior researchers who are coding parts of cars, parts of self-driving systems, and they ask ChatGPT or other large language models to generate code. And these large language models are very good at generating code, and it's possible that even snippets of code can work individually okay. But when you start to integrate them into larger systems, we have no idea what the latent errors could be, what the possible hidden catastrophes await when you start to kludge together code generated by ChatGPT. So I'm really concerned about, from a coding perspective, how are we going to ensure that all this, the Frankenstein of code that we're likely going to get, as you know, and we've already got that problem, but it's only going to be in spades when these ChatGPT creations start to show up in the code, and they probably already are.
And you would think that any code that you generate from anywhere has to be tested, right? You're always testing your code to see if it works. How does that different from what, say, okay, I need some code to do this? Well, you plug in the code. Well, now we're going to test it to see if it works. So,
well, I mean, there's all sorts of basic software development testing, regression testing, for example, that happens, but it's not clear yet how to test code that's non-deterministic, like what comes out of neural nets, especially to what we call in the edge cases, which turns out not to be edge cases that we normally think about, right? So the articulated bus versus the regular bus. Mm-hmm. You don't need to ever, once a human being sees a bus and knows that thing is a bus, when you're two, from then on, you know that even an articulated bus is a bus. Nobody even had to tell you that that was a bus. You just figured it out. Unfortunately, AI needs to be taught every single thing. And we don't really know what the limits of that every single thing are. So we're continuing to find that out. So in that case, for example, turns out articulated buses were an edge case for it, but nobody understood it was an edge case. And so there's going to be a lot of trial by fire, and we need to stop that. We cannot be having vehicles, safety critical systems, running around the road, learning that things are bad only after they do them.
Mm-hmm. Mm-hmm. Yeah, it's very much the Silicon Valley model, right? And in situations where you're writing code for when you were first developing Microsoft Word, okay, things didn't work out for some reason. You know, some code may not have worked, but to do that on a vehicle, and now people's lives are at stake, and property, but especially their lives are at stake. It's really different animal when you start talking about we're just going to put stuff out and break things, because breaking things means potentially people dying, and it's a very a tricky business when you try to bring in the model of the tech industry into autos. But I really saw I really liked your discussion about the regulatory challenges of doing this, and the responsibility for by the manufacturers. You know, I guess I think we could end this discussion a little bit on the responsibility story about accidents. You know, when the cruise automation vehicle runs into something and creates an accident, is General Motors responsible? Well, Cruise is probably a subsidiary of General Motors, but are they responsible? If there was ever an autonomous vehicle sold to an individual, and that vehicle got in an accident, is that individual responsible, or is the manufacturer of the vehicle responsible? How are you thinking about this?
Well, I'm not a lawyer, but I've been around several of them a lot lately with self-driving cars, and so I think that there will be no question that the car companies, if and when for example, a pedestrian is killed, it's just a matter of time before that happens. I think the car companies have done a good job up to this point in not getting to that. You know, they've been very careful, I think, to make that not happen, except that statistically it's eventually going to happen.
Mm-hmm.
And I think that that will be kind of the test case for then what happens in the future with other cases. But I think that the car companies will pay. I think that they will be found guilty. I think that, you know, we'll see what the payouts are. But I think we saw with the case in Tempe, Arizona, you know,
With the Uber driver.
Uber driver, right? But the thing about that is that there was a human to blame.
Right.
And that's kind of the thing. We like blaming humans. And so as long as we can blame a human, we will. But if there's no human to blame in the car, the next human to blame is the company. And we're going to want to hold somebody responsible.
Yeah. The owner of the vehicle, and then the maker of the vehicle.
Well, I do think that's probably where right now the owner and the maker are the same things for Waymo.
Yeah.
Yeah. And you can see later in the future that may change. And
right.
if and when it does change, I do think that, so this is where that AI maintenance problem is going to start getting tricky, because the question will be, did the manufacturer update the algorithms and the onboard AI at the correct frequency? Or did the operator, you know, neglect cleaning the sensors, for example? This is a whole something else people are just not thinking about. Yeah. You're going to have to keep these sensors clean. You're going to have to make sure that you attend to any of the issues that could cause problems for the AI. So, you know, from a legal perspective, I think the lawyers are going to have a great time sorting out some of these complex issues, because who actually made the mistake in sensor care versus algorithm care? I think that's going to be a big debate in the future.
Good point. Good point. Very good. I think we're going to leave it there. Missy, I want to thank you for taking the time today. Very insightful analysis of the issues related to AVs as well as AI within AVs. And again, thank you very much. And we'll talk to you later.
Okay. Thank you for having me.